This section looks at the energy transfers in reactions. Most chemical reactions become hotter or colder as they proceed. They either give out or absorb heat. Reactions that give out heat are called exothermic reactions. Reactions that take in or absorb heat are called endothermic reactions. This clip looks at some exothermic reactions.
This is a strip of magnesium metal. Drop it into hydrochloric acid and watch using a heat-sensitive camera. Blue is cold, purple is warm, yellow is hot, white is even hotter. Clearly the reaction releases heat. It's exothermic. You don't even need solid chemicals for an exothermic reaction. The water in this beaker is at room temperature, but add another cold, clear liquid and a bubbling reaction starts immediately. The heat-sensitive camera reveals gas being given off. It shows up because it's hot. The heat seems to come from nowhere, but actually it was locked up in the chemicals all along.
There's a very exothermic reaction called a thermit reaction. This creates a vast amount of heat and has some useful practical applications.
The grey powder is aluminium. The rusty red powder is iron oxide. We put the mixture into a ceramic pot to withstand the intense heat. A thin strip of magnesium acts as a fuse. The reaction is highly exothermic. It clearly releases a huge amount of heat. What you can't see is why. What's happening inside the reaction. At room temperature, aluminium and iron oxide don't react. It takes the heat from something like burning magnesium to get them going. After that, the magnesium isn't really part of the show. The fireworks happen through this reaction, because aluminium and oxygen are both such reactive elements, and they're desperate to get together. Metal aluminium goes in, and it comes out oxidized. But the iron oxide that goes in comes out reduced. You could say that the oxygen has swapped partners. It's gone off with the aluminium and dumped the iron. Here's the proof. At the bottom of the ceramic pot we made a hole, so whatever was left behind by the thermit reaction would drip down into this sand-filled bucket. It's iron metal. Because the thermit reaction combines both reduction and oxidation, it's called a redox reaction.
The thermit reaction is a redox reaction, a combination of reduction and oxidation. While the aluminium is oxidized to aluminium oxide, the iron oxide is reduced to metallic iron. The reaction also releases a huge amount of heat, which melts the iron. The thermit process can be used to weld railway lines and other metals. An endothermic reaction is the opposite of an exothermic reaction. It absorbs heat, like in this instant ice pack.
Inside the pack are dry ammonium nitrate crystals and a small bag of water. Break the bag open and the reaction starts. The heat-sensitive camera shows the water as yellow. It's quite warm. Black shows where the mixture is much colder, as the endothermic reaction between ammonium nitrate and water takes heat out of the beaker. Quickly, it's down to just 5 Celsius, as cold as a fridge.
So, in an endothermic reaction, heat is taken in from the surroundings to create the cooling effect. There's more about energy transfers in reactions in the Higher Tier Science programme. That's the end of the whole section on patterns of chemical behaviour. That's the end of this Foundation Chemistry programme. There are other programmes about biology and physics, which all help towards grade C. And there's a higher tier science programme for those who want to aim higher. And don't forget, there's also the GCSE Bite-Sized Books and the GCSE Bite-Sized website at www.bbc.co.uk/revision, where you'll also find an interactive online test so you can quickly check what you know.